Boy, I'm glad I caught it now and not at 9:50. You can view the lecture in this class either in person, Tuesdays in BU 102, and attend lab in BU 210. You can watch via WebEx, and the link to my room is indicated within Canvas, or you can watch asynchronously by simply viewing the videos. The videos will be posted to YouTube shortly after the class is complete. Usually within the next hour after the class is complete. Now, there's some situations where it might not be precisely posted an hour after the class is complete, but for the most part, I usually try to get it done immediately. You can assume that by early evening, the class lecture will be posted. If it's not posted by early evening, by all means, send me an email. It's possible that it slipped through the cracks on that day, I forgot, or whatever. And a reminder is fair enough. All right. So that's the way that you can view this class. You have the choice of the three-way. My aim is to be as flexible as humanly possible in getting you the material. All right. If you have questions about this or anything in the class, by all means, email me. For this first week, review the syllabus, review the stuff in the Getting Started folder, module, I should say, and then review the stuff in the week 1 module. The one thing that I was going to mention that I have not mentioned is that we only have in-person class on Tuesday. All right. The rest of the material will be online. And I'm extremely flexible as far as when I can meet you. So if you're having difficulty with the material, schedule an appointment. I can't encourage you to do that enough. I don't want to see you grinding away, working on something and making absolutely no progress whatsoever and getting frustrated. Sure, spend some time trying to figure out the homework assignments. But if you're really stuck and you feel that you're not making any progress, by all means, don't just sit there frustrating yourself. Get some help. And if you email me, I can arrange to meet you online or even possibly in person if that works better for us. So please take advantage of that. Some of you have probably had me in classes before. Some of you maybe have not. But I do my best to, connect with students on their terms and when they're available. So all my office hours are arranged, and we can typically make them, during the day, during the evening, even on the weekends, if that works out for you. Do give me a little bit of time, though. If you, for example, if you were to contact me today, don't expect that I'll be able to see you today. I might be able to, but it's possible I'll tell you that I can meet you sometime tomorrow or whatever. When you contact me for assistance, give me a list of times that work for you. So, if you can meet me Monday, Wednesday, and Friday between noon and 5 p.m., tell me that. That way I can look at my schedule and I can schedule a time that works for the both of us. That just saves a little time going back and forth exchanging emails about arranging a time to meet to discuss with me. Okay, let's look at some of the materials here and as we begin examining the actual course itself. Let's look at this one.
Question.
Oh, this is the
Would
video.
you build a web?
Never mind. You can watch this one. I thought this was a diagram. My mistake. I'm going to draw the diagram. Let's talk about what happens when you access a web page. And I'm not talking about accessing a web page that's on your machine. For example, what many of you did for CISS232, or pretty much all of you did, is you've created the web page on your machine, you've saved it, and then you double click on it to open it. That works a little bit differently than this. What we're talking about is when you access a site that actually is on the internet. what happens? All right. First of all, we're going to throw some terms out here, and these are common terms that we're going to come back to throughout this class and other classes that you have. First of all, we have the client, all right? The client is the person that is accessing the website, all right? It could be someone with a computer running a web browser. A web browser is the application that allows you to access websites, all right? It could be someone with a phone that's accessing the web. So many people now don't use a computer to access the web. They use their phone. So you can go to Google or whatever on your phone just as well as you can do it from your desktop. Could be someone in a gaming console. Many gaming consoles have web browsers built within them. It could be another program, all right? For example, Google, when it goes through and finds the websites that are available and indexes them, it uses what's called a web crawler, which goes and looks at what sites are available and then creates an index for them. All right. So a client is any entity which requests a web page. It's going to take me a second to learn how to write with this pen. Client is responsible for making requests of a web page. That request typically goes through the internet, which I'll represent as a cloud. Somehow, it gets routed to the correct web server. Now, what's a web server? A web server is a computer system that is set up to respond to requests. All right. So the request comes through the internet, gets sent to the right user or gets sent to the right web server, and the web server sends back a response. And that response usually is the web page that the client has requested. So if you go to lorainccc.edu, your request travels through the internet, makes it to Lorain County Community College's web server. The web server does what it needs to do to prepare the response, and then it sends that response, and that goes back through the internet to you. Okay? Request, response, client, and server are the key terms in this interaction. Exactly how it gets from your client to the web server is not something we're going to cover in this class. Simply put, every computer has an IP address, and web servers have IP addresses, as do the client. And those IP addresses are used when you type in a URL. That URL gets translated into the web server's IP address, and through the magic of TCP/IP, the request gets routed to the correct web server, and the response back gets routed to the correct client. So we're not going to really spend too much time talking about that. Okay. Now, let's look at how the web server responds to the client's request. The kinds of pages that you created in CISS232 are what are called static pages. And the word static in this context means that they're unchanging. simply made of HTML and CSS. Right? The web server's job is very easy for these kinds of requests. When the client makes a request for a static page, that request goes through the internet, gets sent to the web server, and all the web server does is finds the file on disk and sends that file back to the client. So the response here that the client is going to get is HTML. It kind of uses as a pointer. The request goes through the internet, the web server. The server finds the static file or files, and sends them back to the client as an HTML page. And when I say HTML page, I might abbreviate it by saying HTML page, but I'm also talking about pages that contain CSS and maybe JavaScript. Now, here's the interesting thing. No matter what technology the web server uses, typically the response that the client gets back from the web server is HTML, CSS, or JavaScript. And JavaScript, rather. The analogy that I give is this. Compare it to going to different fast food places for a sandwich. All right? If you go to McDonald's and order a Big Mac, chances are that Big Mac has already been made and is sitting in a bin. And the server at McDonald's, all they need to do is grab the Big Mac out of the bin and give it to you, the customer or the client. Right? Those pre-made sandwiches, which are sitting in a bin waiting for someone to ask for them, are like static web pages. They're made in advance. They're made with a certain content. In other words, those sandwiches in the bin contain the standard condiments in them, the ketchup, mustard, whatever, special sauce, pickles, onions, whatever's on a Big Mac. And they can't be easily customized for request. All right. So those are like static web pages. If you request a static web page, everyone requesting that web page will get back the same web page that will show the same content. All right. Remember, the word static means unchanging. For example, if you were to go back to your assignments that you did in CISS232, the Intro to Web Development, if you were to look at them today, they're going to look exactly like they looked the day that you turned them in, unless you've manually gone and changed those pages. That's what a static page is. But if we think about it, a lot of things on the web aren't like that. For example, if we go and Google something, let's say I Google HTML. That appears a certain way. That web page that I get back from the server looks a certain way, has information about HTML, has the commonly asked questions, and has some other information here. If I were to Google CSS, I've gone to the same page, yet the content of the page is different. The content of the page is customized based on the term that I entered in. Right? That's not going to be a static web page then, because with static web pages, they stay the same regardless of how you request them. These are dynamic pages, and these dynamic pages change depending on a variety of factors. In this case, for example, the dynamic pages change based on the input that you've given them. If you've inputted CSS, it gives you one thing. If you've inputted HTML, it gives you something else. With Google, actually, it gets more involved than this. If I were to Google Italian restaurant, notice what it shows me. It shows me Italian restaurants near where I'm at. I'm on campus here at Lorain Community College. So the results it shows me are, here's a restaurant in Sheffield. Here's a restaurant in, that's probably Elyria. Here's a restaurant in North Ridgeville. Here is a TripAdvisor page, the 5 best Italian restaurants in Elyria. There's a Yelp page, the best 10 Italian restaurants near Elyria. Here is the Olive Garden Midway Mall location. Now, it should be pretty clear that not everyone in the world would get this exact same results that I've gotten here. As good as Sorrento's is, which is it's a good restaurant, I've eaten there, it's not necessarily the #1 Italian restaurant for everyone in the world. So if someone in New York City, for example, were to Google Italian restaurant, they're going to get a whole different set of Italian restaurants. All right? They're going to get the Italian restaurants that are near to them. If someone in Italy were to Google this, they're going to get a different set of restaurants, and so on and so forth. So obviously, these are not static pages because not everyone gets the same results. These results change based on something. And in this case, they change based on the client's location. What does that mean for us? Getting back to our diagram. Well, that means, first of all, that the request, I'm going to try to draw an asterisk here. The request for us is more than just a URL. The request includes a URL. It also includes information about location. Specifically, it gives an IP address, which the web server can use to compute the location of the client. It gives any data from the forms that we've entered. And in the case of Google, it gives us a bunch of other stuff too. It has access, for example, to our search history. If we were to Google something that is has relevancy in multiple contexts, it's going to give the context that it thinks is most relevant to us. Let me give an example of that. I'm going to Google Don Cherry. Now, there's 2 semi-famous Don Cherries. One of them is a hockey player and a TV announcer up in Canada. One of them is a jazz musician. So if I Google Don Cherry, I'm not logged on here, so it has no access to my search history. So it doesn't know what Don Cherry I mean. So it gives me both. It gives me the Wikipedia article for the hockey Don Cherry. It gives me the Wikipedia article for the jazz player Don Cherry. Hockey, jazz, jazz, hockey, hockey, and so on. Now, given that I listen to jazz more than I follow hockey, if I were to Google this from my machine, having done more search about jazz musicians and so on, is going to take that into account when preparing the search results. So therefore, it's going to give me, it would probably give me more of the results about the jazz musician than about the hockey player. All right, so the thing to keep in mind is this request is not simply just the URL. It contains other information as well. It contains the URL, it contains information about the user's location, specifically the IP address that can be mapped into a location. It sends me, gets sent data from the forms, for example, the search term that we enter in. It will give me the platform. The request contains the platform. So when I Google something, it knows whether I'm on a Windows machine or a Mac. All right. And it gives us a whole bunch of other stuff too. Okay, so that's the client's responsibility as far as the request goes. That request goes through the internet and makes it to the web server. Thing about this is it doesn't matter what platform the client's on, what platform the server's on, as long as they all follow the same protocol. As long as the client does TCP/IP and as long as the server does that, and as long as they both do the HTTP protocol, they're able to communicate and access web pages. The client access web pages from the server. Now, these static pages are finished HTML pages. All right. Dynamic pages are not finished HTML pages, but instead are scripts. Now, these scripts are not HTML or JavaScript or CSS. These scripts, however, create HTML, JavaScript, and CSS. And they are written in languages such as PHP, Ruby, ASP.NET, Razor Pages, JSP pages, Java servlets. Any, oh, the name just escapes me. The Java-based one, JavaScript-based one. I can't remember off the top of my head. This is terrible. But the point is that they're not completed web pages. They're scripts for web pages. Right? Now, these scripts might contain some static HTML and CSS and so on. However, the guts of the page are derived and created dynamically on the fly by the web server. And that will often involve working with a database. So for example, when we do a Google search, there's a script that's on the Google web server that accesses the Google indexes, however they're stored, and comes and puts them all together and gives us a response, and that response comes back to the client as an HTML, CSS, and JavaScript page. Important thing to remember is that no matter whether it's static or dynamic, the client gets delivered a web page because that's what clients want. That's what clients are requesting. Think of dynamic as being like Subway, the Subway sandwich shop, instead of like McDonald's. Subway doesn't have a bin filled with every possible Subway sandwich that you can order. It doesn't have a bin with chicken and mayonnaise, chicken and mustard, chicken with spinach and vinaigrette. You know, it doesn't have all that. That would be absurd. Just like Google doesn't have a page pre-prepared for everything you could possibly search for. It creates it on the fly based on your input, just as the sandwich maker at Subway creates a sandwich on the fly based on your input. All right. And as far as ordering sandwiches go, when you're done, whether you get a static sandwich like at McDonald's or a dynamic sandwich like in Subway, the client gets delivered a sandwich. Same thing with web servers. Whether the web server uses static web pages or dynamic, the request is satisfied by delivering to the client a web page. And by that, I mean a page containing HTML, CSS, and JavaScript. Okay, so that's sort of the name of the class, right? Scripting in the client-server environment. So we see now how we have scripting, and scripting is just another name for programming, both on the client side and on the server side, yet they each perform different roles. Scripting on the server side is typically the heavy lifting. And by heavy lifting, I mean the secure things that need to be done securely, the things that require interaction with other systems, that require interactions with databases, and so on. That's something that would be either impossible to do on the client side or undesirable to do on the client side. You wouldn't want code on the client side that could access your database, for one thing, all right? Because we want our web pages accessible only via the browser, and the browser is a very simple program. We don't want to have the client loaded up with all kinds of programs needed to view a web page. So all that heavy lifting goes on the web server side. All right, so the code that actually looks at the request and pulls the data together from the database in response to a Google query, that happens on the server side. That's too big of a task to ask to be done on the client side. The client doesn't have access to Google's database, and it would be very insecure or impractical, or, you know, for all intents and purposes, it would be impossible to do that on the client side. Instead, you let the web server do that. Okay, so what kind of scripting does the client side provide? In general, the kind of scripting that client side provides is something related to interactivity. And what do I mean by interactivity? I mean, in general, you do something, that is, the user does something on a web page, and the web page responds to it without reloading it on the server. Remember, when the page gets delivered, not only does the client get back HTML and CSS, they also get sent back JavaScript. That JavaScript is responsible for making change to a page after it loads. It's the key difference between server-side scripting and client-side scripting. With server-side scripting, the scripts run in order to prepare the web page that gets sent back to the client. All right? Client-side scripting relates to making changes to pages that have already been delivered to the client. So kind of what runs first? Well, the server side runs first. It is used to create the web page. Then it gets sent back to the client. with the necessary HTML, CSS, and JavaScript. And that JavaScript allows the client to interact with the web page without having to go back through the server. The example that I often use for this is if we visit ESPN's website. Notice that we have a list of menu items up here. NFL, NBA, Major League Baseball, soccer, NCAA football, Little League World Series. Notice when we put our mouse over one of those items, a menu appears. Notice also that that happens immediately. What can we conclude about the fact that it happens immediately? There's no lag. It doesn't take a second to happen. It means that there is code on the client side that makes the one section of the page visible and other sections of the page invisible. So all those menus get delivered to the client and are set to invisible. When the user puts their mouse over something, the thing that the user put their mouse on gets shown, and the other ones remain invisible. That happens immediately. It doesn't require this trip over the internet, all right, for the request to be made. It travel throughout the internet, end up getting to the web server, and then getting responded back and sent to the client. Another tip off is notice when we refresh a page, get a little status here indicating it's waiting for the server, connecting, waiting for server, and so on. We don't get that when we put our mouse over it. It just shows us the URL if we click on that link. I hope some of this is review for you to sort of set the stage for us. And the next thing we're going to do is actually look at the details of JavaScript and see how JavaScript works. All right. Keeping in mind that the key to JavaScript is the interactivity, that it allows the user to do something to the page and get a response back. Now, JavaScript works very closely with the HTML and the CSS of the page. The JavaScript on the page can access and manipulate these properties. Getting back to the ESPN page, when that page is initially loaded, all those submenus are invisible. And we could think of how we would do that in CSS. We could set the visibility to invisible. We could set the display to none. So we could do this a couple ways. Do that to make something appear or disappear. When we put our mouse over it then, all right, we change that visibility setting from invisible to visible, or the display to block, so on. Then by careful CSS, we make it appear directly underneath the menu item. So NFL is underneath NFL, NBA is underneath NBA, and so on. This is HTML. The fact that it's in this position and visible is CSS. And the fact that we can change that visibility is JavaScript. So let's start with a very simple example. I'm going to create an HTML page, and I'm going to use for editing that page, I'm going to use Visual Studio Code. I sort of have gotten to using that for most of my programming needs. Other than that, which I use Visual Studio for. I'm going to create a new file. And I can say I want to create a new HTML file. All right, something happened. I can select a language here or open a different editor. I'm going to select that I want an HTML file. The nice thing about that is it gives us IntelliSense. So do this very quick. We have a couple minutes left in class, about 10 minutes. We'll try to get this complete example in. It's the ending tag for us. We've done something similar to this in CISS 216. But I want to review this. This is sort of a very much scaled down version of the ESPN thing. Make all the divs on the page invisible. So we see that the content of my submenu is in HTML. The initial display is controlled by CSS, and we dynamically change that style via our JavaScript. Save this on the desktop. I think I saved it on the desktop. It doesn't work. Well, let's find out what it doesn't work. I use Google Chrome, and if you look under development tools, it will tell us absolutely nothing. Oh, got an extra quote in there. Mouse over. Yeah, I'm still getting used to getting up early for school. There we go. Page initially loads, it's set to invisible, put my mouse on it, it displays. Three things working together: the HTML, the content, style of it, and JavaScript that dynamically changes the style of it. And we can change anything about the HTML or the style of the elements on the page. We can change dynamically using JavaScript. All right, let's take a look at your first homework assignment. First homework assignment does not require you to do any JavaScript. Instead, what you'll do is you'll look at the main topics of this class. JavaScript, PHP, and Ajax. Investigate these topics. Sketch out how you want the page to look and create your web page. And have 3 links about each. So find out what JavaScript is. You should already have an idea about that. Find out some information about PHP and find out information about Ajax. And you should then create a web page. Now, use these examples not just to complete the assignment, but to do a good job with the assignment. And what I mean is make a page that looks like a completed web page. All right. Style it somehow. Make it look good. All right. A little bit of effort goes a long way in making your web pages look a lot more professional. So take the time and don't just complete the basic requirements of the assignment, but sort of go beyond that and really do a great job on that. Are there any questions? Yeah, the sandwich analogies. I love them too. You'll notice that in many of my classes, I use food analogies because that's something near and dear to my heart. So, all right. We will remember, we do not have class on Thursdays. You can review the material that's posted online on, the rest of this week. If you have any questions or problems, let me know. Okay, sounds good. All right, I'll talk to you later then. Have a good one.